Today we're going to talk about arithmetic sequences. We started to mention them last time in our 9.1 video. Today's learning objectives are that you will find the common difference for an arithmetic sequence, write the terms of an arithmetic sequence, use a recursive formula for an arithmetic sequence, and use an explicit formula for an arithmetic sequence. So those are the goals of 9.2. The skills that we're going to talk about right now, though, are going to be to determine if a sequence is arithmetic and to find the general or nth term of an arithmetic sequence. So I will talk about these things as well as we go through. The first thing we want to talk about, though, is what is an arithmetic sequence to determine if a sequence is arithmetic. So an arithmetic sequence is a sequence where the difference between consecutive terms is always the same. The difference between consecutive terms is going to be called D for difference, and is called the common difference for n greater than or equal to 2. We have to have at least 2 terms to be able to find the difference between those 2 terms, because subtraction requires at least two numbers that we're finding the difference of. It's a binary operator. So we have to have side-by-side terms. So in this example, if we wanted to find out that to get from 7 to 10, we needed to add 3, we could do that by saying 10 minus 7 is 3. We could do the same thing with the next pair of terms. 13 minus 10 is also 3. 16 minus 13 is also a positive 3. 19 minus 16 is also a positive 3. 22 minus 19 is also a positive 3. So we see that the difference between any term and its previous term in the sequence there is D, which is a positive 3 in this case. And I identify that D is equal to 3 in this case. Likewise, we can say 4 minus 8 is a negative 4, 0 minus 4 is a negative 4, negative 4 minus 0 is 4, negative 8 minus a negative 4 is a negative 4, negative 12 minus a negative 8 is a negative 4. So we see that our common difference here is negative 4. Negative difference is going to make our sequence decrease. A positive difference is going to make our sequence increase. Now we're going to determine if a sequence is arithmetic. And if so, we're going to find the common difference. So we're going to look first at the sequence 5, 9, 13, 17, 21, 25. Let's find the difference between consecutive terms. 9 minus 5 is 4. 13 minus 9 is 4. 17 minus 13 is 4. 21 minus 17 is 4. 25 minus 21 is 4. They all have a common difference of 4. Therefore, it does appear to be arithmetic with a common difference of 4. The next sequence we're going to look at is 4, 9, 12, 17, 20, 25. So 9 minus 4 is 5. 12 minus 9 is 3. We can stop right there because 5 is different than 3. It's not arithmetic. There's not a common difference between consecutive terms that's the same for everything. Now there is a sequence here where we're adding 5 and then adding 3 and then adding 5 and then adding 3 and so on, but it's not a common difference. So we can't call this one arithmetic. Let's go ahead and let's look at what we have here. Negative 4, 4, 4, negative 4, 4, 2, 10, 8, and 16. So 4 minus, let's just see if they just gave me some space to work. So find the difference between terms here. So let's write 4 minus a negative 4. Then we're going to have 2 minus 4. Then we're going to have 10 minus 2. Then we're going to have 8 minus 10. And we're going to have 16 minus 8. 4 minus a negative 4 is 4 plus 4 is 8. 2 minus 4 is a negative 2. We get an 8, then we get a negative 2 again, then we get an 8 again, and we assume that that pattern continues, but this is not arithmetic. Because there is no common difference. Okay, so now let's move on. Negative 3, negative 1, positive 1, positive 3, positive 5, positive 7. So we're going to have negative 1 minus a negative 3, 1 minus a negative 1, 3 minus 1, 5 minus 3, 7 minus 5. So this is going to be negative 1 plus 3 is 2. 1 plus 1 is 2. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. And so it looks like we have a common difference of D equals 2. And yes, this one is arithmetic. All right. So let's move on to example 2 here. And we're going to switch objectives. And now we're going to be given a common difference and an initial term. And we want to write out the first few terms of the sequence. So if I'm told here to write the first 5 terms of the sequence, whose first term is 5 and whose common difference is negative 6, then 5 plus negative 6 is going to give me negative 1. And then negative 1 plus negative 6 is going to give me negative 7. Negative 7 plus negative 6 is going to give me negative 13. Negative 13 plus negative 6 is going to give me negative 19. So that forms a sequence 5, negative 1, negative 7, negative 13, negative 19. Another way that I could look at this is that I keep adding negative 6 each time. So I could start with this 5 and then first add 1 times negative 6, then 2 times negative 6 to that 5, and then 3 times negative 6 and 4 times negative 6 and so on. So we're going to get to that type of formula here for it in just a second, and that'll help us generate terms that are way out here on the end. So let's practice writing these terms, though, of this sequence. We're going to be starting with negative 4. And each time we want to add 7. So negative 4 plus 7 is going to give me 3. 3 plus 7 is going to give me 10. 10 plus 7 is going to give me 17. And 17 plus 7 is going to give me 24. And those are my first 5 terms of my sequence. So now we're going to work on the general or the nth term of the sequence. And we're going to do exactly what I was just saying. Look at it, that the difference here between these is D. So I'm going to add 1 times D. The difference to get over here is going to be 2 times D. To get all the way over here is going to be 3 times D. Get all the way over here to term 5 is 4 times D. So it looks like I'm always adding a coefficient of 1 less than this term times my common difference. And sure enough, there's my formula that AN is equal to A1 plus N minus 1D is going to generate the nth term of the sequence. So let's go ahead and let's find the 21st term of a sequence whose first term is 3 and the common difference is 8. So we're going to change those words into our symbols here. The A1, my first term, is 3. My common difference is 8. And I want to find, when n equals 21, I want to find the 21st term. So A21 is going to be equal to 3 plus, and then in parentheses, 21 minus 1 times 8. We got to do what's inside the parentheses first. So 21 minus 1 is 20. Now we need to do our multiplication before our addition. So 8 times 20 is 160. And as a final step, we do our addition, 160 plus 3 is 163. So our 21st term of this sequence is 163. This is an explicit formula that we were able to get to the 21st term without going through terms 1 through 20. So let's go ahead now with another example. We are given that the third term in the sequence is 19, and the common difference is 5, and we want to find the 11th term. Okay, so we're just gonna let's see how they chose to do this here, and let's hope that they used the right numbers. Let's see. So find the 11th term, or the third term is 19, and the common difference is 5. Okay, so how many more terms did we need to go to get from the 11th term to the between the third term and the 11th term? Let's just ignore this work. I think they did their work wrong here. So first thing we need to find is that what is A1? Oh, that's what they're doing here. Okay, and then they'll go on and they'll do it the other way. So A3 that they told us here was 19, and that is 3 minus 1 is 2. The common difference is 5, so we can go backwards and we can find A1. It is possible to treat this term here like it's the first term and find out how many steps that I took, but they didn't do it that way. So they're gonna take 19 minus 10 gives me A1 is 9. So we're going to hang on to that. We know now that A1 is 9. Lots of typos in this. Sorry, guys. And then the common difference is 5. And we know that we want to go out to the 11th term. Okay, let's see what they did there. So then we're going to say that 9 goes in place of A1 here. 11 minus 1 is 10 steps to get out to the 11th term. 10 times 5 is going to give me 50, and 50 plus 9 is going to give me 59. So the 11th term is going to be 59. Let me show you that I could have done it a different way here. So this is what I was thinking. If I wanted to go from 3 to 11, that's going to be 8 steps, right? So get from A3 to A11, I want 1, 2, 3, 4, 5, 6, 7, 8 steps. So I need to take my A3, my A11 is going to be equal to A3 plus 8 times my D, because the difference between 11 and 3 is 8. So that's going to be A11 is going to be 19 plus 8 times 5 is A11 would be 19 plus 40 is 59. There's more than one way to do this. That's what makes arithmetic sequences great, is that I can just count the number of steps that I need to take, and that's what I'm going to use for multiplication. So I just got here that the difference between my indices on my terms, 11 minus 3 was 8. And that's how I knew what my multiplier there was. All right. Now, if I want to practice this, let's find the general term, the nth term of this arithmetic sequence. Find this explicit formula here is what they want. Find the 16th term. So I want A16 going to be equal to A1, which is going to be 11 plus, and then this is -6. Sorry, that is, the common difference is -6. They want -6 there. And then this is the 16th term, 16 minus 1. So our A16 is going to be 11 plus 15 times -6. 11 minus 90 is going to be a -79. So I didn't have to go through all those steps to get to -79. I just got straight to my -79 for my 16th term. Now let's find the 19th term whose sequence whose 5th term is 1 and the common difference is 4. So I want A19 equals what? And I've got A5 is 1 and the common difference is -4. So let's do this the second way that I said to find that my number of steps that I need to take here, A19 is going to be equal to A5 plus, and then 19 minus 5 is going to be 14 times my common difference of -4. So A19 is going to be A5 was 1 minus, that's 16, that's 56. So I get A19 is equal to a -55. You can go ahead and check it the other way if you want to, the way that they did their example where they went and first found A1 and then used A1 to go ahead and find AN. So if we want to, over here on the left, say that, let's go ahead and check it that way, see if we get the same answer. A5 is equal to A1 plus n minus 1 is 4 times our D is -4. Then we have 1 is equal to A1 minus 16. So A1 is equal to 17. If I have that, then AN is equal to 17 plus n minus 1 times D. So A19 is going to be 17 plus 18 times D is -4. A19 is 17 minus, and then this is 32. That's 72. So A19 is going to be a negative. 72 minus 17, we're going to borrow. 12 minus 7 is 5. This is 55. It's a -55, right? Here. And we got the same answer 2 different ways. Look at that. So, okay. Let's move on. Oh, we're done. So another thing that you can do if you want, it's a little harder, is if you want to start counting at 0 instead of 1 for these sequences, your formula is going to change a little bit. And it's going to look like this, that your AN is going to be equal to like that. So if I usually deal with this rule. So I would look at this and I would say, okay, my initial term was, and it would just decrease this n by 1 that you're dealing with. So anyways, you can do it that way too if your textbook does it that way and defines your sequences over the whole numbers instead of the natural numbers. But this textbook is always starting with the first term being at 1, because most people start counting that way. They don't start counting at 0. All right, we will come back and talk about geometric sequences next time.